In this video, we will be talking about acids and bases. There are three different classifications: Arrhenius, Bronsted-Lowry, and Lewis. For an Arrhenius acid, any species that creates H+ in water, and for an Arrhenius base, that would be any species that creates OH- in water. So which of these molecules would be an Arrhenius acid? HCl, sodium hydroxide, CCl4, or ethane. And so ethane is very inert, so it will not create H+ in water. We have CCl4, it will also not create H+ in water. We have NaOH, which is a salt, and so that will not create H+ in water. So we have HCl, our final option, which will create H+ in water. For an Arrhenius base, we have the options of NaOH, FeBr3, HI, or a carboxylic acid. With HI, we would get H+ and I-. That would not create O- in water. And the same thing with the carboxylic acid group, which would lose that proton. We have FeBr3, which will not create OH- in water. And so our final option is Na+ and OH-. So sodium hydroxide will create OH- in water. For Bronsted-Lowry, a Bronsted-Lowry acid is any species that can donate a proton, and a Bronsted-Lowry base is any species that can accept a proton. So which of these molecules would be a Bronsted-Lowry base? So we have H3O+, which is going to donate an H+, so that will be an acid. We have the same thing for the quaternary ammonia, that will donate an H+, and the same thing with HBr. So the correct answer would be an H3, because it can accept a proton and it will become an H4+. For the Bronsted-Lowry acid, we have ethyl ether, methane, another carboxylic acid, and NH2-. NH2- is negatively charged, so it's not going to want to donate another proton, it wants to accept another proton. So that would not be a Bronsted-Lowry acid. We have methane, which is inert, it is not going to donate a proton. And the same thing with ethyl ether. So the correct answer is the carboxylic acid, because it's going to be able to lose that proton. For a Lewis acid, that would be any species that can accept electrons. And for the base, that would be any species that can donate electrons. So for a Lewis acid, we have OH-, NaOCH3, FeBr3, and NH3. For NH3, it actually already has a lone pair of electrons, so it's not going to accept more electrons. HO- is already negatively charged, it is not going to accept more electrons, and that's the same for NaOCH3. So the correct answer is FeBr3. For the Lewis base, we have hydronium, and this is going to donate the proton. So this is not going to donate electrons. It is going to donate protons. So this is not the correct answer. We have methane, which is going to be very inert. We have AlCl3, which is going to accept electrons. So it will not be the correct answer. And so the correct answer is CH3 and H2.